body to this speech. I try to make it interesting for you, because technical debt concept by itself, from one hand, it is easy to grasp, but when you ask a couple of people, try to compare their answers, they might be pretty much different when it comes to details. Today, I would like to cover this aspect, which has a bigger challenge that aspect, for example, like extrinsic external aspect, like defects for the quality of the software. With a technical debt, this is internal value and internal challenges we may face. So first of all, we will discuss the challenges between business perspective and engineering perspective on technical debt. Then I will present the model and the approach we could use to have this perspective meet on the common ground. And last but not least, I will walk you through the results of 3-year-long experiment which was held in video area for a camera configuration product. So the biggest challenge when we have when we talk about technical debt is the perspectives. So engineering sees the business that they are focused mostly on the short-term business perspective, and the software is actually in a not such a good condition. And that business is seeing the refactoring or the taking care about the internal product quality as something which is totally not value added. On the other hand, from business perspective, they are seeing engineering as they may have just a tunnel vision, they would like to polish, and they have this craftsmanship sense over the real value of the product, and they neglect future direction and actually business case and earning money. So we see that this tension actually puts these two teams or these two perspectives on two other ends. However, in short-term business perspective is not addressed, the long-term simply may not materialize. We need to take care about being able to earn money. On the other hand, if we forget about long-term engineering perspective, which is thinking about the product and its internal quality, then development simply stalls. The features cannot be delivered fast. We are having constant hiccup in the testing, and actually developer morale sinks. And a little bit about the background, what we actually do. So bear with me with this slide, because there will be a couple of definitions to be the common understanding. So thinking about technical debt, it refers to immature software development artifacts, not to something vague, but something which is tangible. And this is very important. They may be expedient in the short term to achieve some business goals, but they introduce delayed consequences, which make sometimes future changes very hard or even impossible. On the other hand, when we think about technical debt for the product, it embraces all actionable product technical debt items. So there is a group of the items to be addressed, informing about deviation from desired optimal state. So when we see in the picture, this is the green area between showing where we are right now and the difference to where we want to actually be. However, this is not only our decisions which made the situation worse, considering incurring technical debt. It may be just the surrounding business conditions. So in our example, which I will show a little bit later, there was the situation about acquisitions. So we took another company on board, and the product suddenly has to support more devices and be able to do it smoothly, which changed a little bit approach to the architecture and actually showed some internal changes which were required to support it. Ultimately, context is the key. What may be technical debt for one product in one company won't be as such for a product in a different company. Why is this so? Because in one company, that component of that area may be something which is already not that much important, not supported. In the other company, it will be the core for the extensive new functionalities. So where we will be investing more, it will have a bigger value. And another challenge, when we talk about technical debt, this is one, but when we talk about the product, is the question what the product actually is. So I invite you to watch this short video from
The software-defined vehicle defines the paradigm shift from hardware-driven to software-defined development. Modern EE architectures and cloud-based services make the vehicle both a sender and receiver of data in the Internet of Things. This allows the vehicle to communicate with its environment, collect data in real operation, and send it to the manufacturer's cloud. Using this data, features and services can be continually enhanced and uploaded to the vehicle using over-the-air updates. For developers, this means a shift from the classic V model with a defined beginning and end to a continuous DevOps cycle. This evolution not only affects development and operation, but also makes new business models and types of collaboration possible. This is how Bosch, together with its partners, is shaping the future of mobility. Bosch, invented for life.
So as we see here, it's very important to understand that the product is not just a car. It's just everything which constitutes the service for the customer. So that's how the product thinking about the product is being broadened. And for example, Craig Larman, which was co-founder of large-scale Scrum approach for scaling Agile, is saying, make the product definition as big as reasonable possible, as you can manage. So this is not about having like a 4 or 8 teams, which is defined. But when I had chance to talk to him, it's just making it as big as your company can support and build the organization to work effectively with it. So this is another puzzle, considering the definition of technical debt, and here is considering the definition of the product. So from our perspective, we should put all software artifacts enabling efficient value creation for a customer in a continuous manner. So not only the product code, as it is normally being thought of, but also the environments, simulators, anything which will support upgrade, maintainability, logging, monitoring in the field, whatever is needed to deliver value to customers. And even for the product, which is traditionally thinking as an on-prem ones, whatever the tooling is being built around, they should be thought of as a part of it and being taken care of in the same manner. But this is not only about DevOps. I'm showing here the picture of Atlassian stack. But what about further expansion? Not only DevOps, we are adding also security, and there is DevSecOps. Sometimes more aspects are being even thought of, like, for example, automation of the conformance testing. And this is also very important to take in mind that whatever we are doing around the product to deliver value is a part of this product definition. So the challenge we are facing is that from practical perspective, we had to treat technical debt management as one of the core engineering practices, and that intuitive actions of engineers, when they are focused only on the improving the software which they have right now be under development, might not be effective considering the long run. What we did was an experiment how to build a technical debt management solution which will balance this perspective, engineering perspective, and the business needs in evolving environment. So we wanted to improve business value, which is being defined as a support for upcoming features in the field. We wanted to also increase the productivity of the team, just to make sure that the intrinsic issues or challenges with technical debt are diminishing. And last but not least, we will see this as developer satisfaction from working on the product. A little bit of the milestones, because this is not just one experiment, this was a set of experiments. There was some work already from my side on adding value to technical debt back in 2012. Then thinking about different perspectives, including, for example, performance for the product. Later on, there was an understanding of technical debt considering all aspects which relates to real software development artifacts, something tangible, because the term became vague and even researchers had a challenge. So the definition which I mentioned was agreed upon in 2016 on the Dutch Tools seminar. Later on, the model appeared, and we included additional perspective, thinking about the broadened product view. Ultimately, the model was expanded and evaluated during this three-year-long journey with the Scrum team. Anyways, all models are wrong, but some are useful. So let's talk about the model. From that perspective, first of all, we need to think about how we define project manager versus product owner cooperation. So product manager is thinking about market trends, reaching customers, getting the feedback from the field, and providing the business evaluation of the opportunities. Later on, we see the business process, which needs to be structured somehow. So the opportunities are being evaluated, worked upon, and we see which may materialize and which are real features which needs to be developed. However, there is no ultimate value which can be assigned to any product. So each team, each business may define it differently. So we see that even in the tools like Savio, Product Board, or AHA, there are different ways to configure the evaluation. But good thing is that for engineering, this is important to know the relative valuation and the priorities, not the exact numbers which are being provided. And these clear guidelines will help to prioritize product roadmap. What we think about technical debt, what we took into account, not just simply code corrections, adherence to coding standard, aligning to this, but something which is bigger, sometimes of the size of the feature, how to enable testing with the simulators, how to refactor modules to improve performance, and how to enable to unified logging monitoring mechanisms. These are just examples. We should avoid putting in the model everything, because applying this is a little bit costly for small tactical items, because for these we should have our processes which should satisfy the conformance here. We simply should use normal like reviewing process and automated code checking. And how it all may work together. We see that business perspective being driven by the product manager is evaluating constantly the opportunities in the field and shuffling the priorities, building the business roadmap, and this information is being provided to engineering. On the other hand, engineering team knows well what are the issues and challenges in the product, and they keep a record of technical debt register, the big ticket items which really require investigation, support, and changes, and they are not so easy to budget for. And here is the clue, our CoDVA approach. So continuous debt evaluation approach for technical debt prioritization acts as a mediator between business and engineering. When we have a clear guidance of the features and clear information about backlog of technical debt, we can map technical debt items and evaluate how much they will support upcoming features in the roadmap. And here is the clue. When we see which features will be prioritized, automatically we got technical debt items reprioritized. So at the end, product owners who should take care about the product internal quality and also satisfying the business needs is getting certain budget for technical debt and taking these items which will have the biggest value for the future. When we think about a little bit of math, how we may put it here, this formula may seem a little bit intimidating in the first glance, but actually this is pretty simple. The most important aspect is this mapping of technical debt effect on actual features on the roadmap as TDIE, but we take into account also other aspects. I will go briefly through this. The very important fact is that this can be computed at any moment and will help allocate priorities for technical debt reduction. We take into account feature priority, the relative value from the business, then the size of the feature which is being developed, and something which we called roadmap scope stability. This is the information, how stable is the roadmap. So if, for example, being in one release, I know that having the scope for the next one may change in 60% of the time, then this is a different information that I know that, for example, 20% of the scope for the next release will survive and actually be part of the actual development. Why this is the issue? It simply shifts the focus. The bigger stability, the higher stability of the feature roadmap, we may simply take into account way more features to consider the prioritization of technical debt. And last piece of the formula, which is here, it's simply the reflection of the tree structure of technical debt. By the tree, I mean that technical debt may have some internal dependencies. So enablers for other items will be prioritized first. Okay, and seeing the example how we may apply it for the functionality. Let's have two product releases, R1 and R2. Then include three new features, F1, F2, and F3, which have different sizes as is being seen here. Then the product managers provide normalized feature priorities. So we are getting this information about prioritization, have it normalized from 0 to 1, and assigned to given features. We have 4 technical debt items and simply make a mapping as the picture shows here in this initial state. And we assume a given roadmap stability, which is 60%. At the very beginning, when we calculate how the priorities may be applied, we are given the prioritization starting from TDI 3, then TDI 2, then 1, and then 4. However, if for certain reason, for example, one of the sales didn't pan out, sales opportunities didn't happen, the priority for a given feature drops to 0.6. It automatically provides that information for the mapping, and technical debt is reprioritized instantly. And then we are seeing that the prioritization after this change changes to TDI 3, 1, 4, and 2. And there is one important aspect to this. When we see TDI 2, first of all, in the first case, it was on the second priority. And after the change of prioritization of one feature, it drops to be the fourth, which means this was a specific TDI item which was heavily bound to particular feature. However, thinking about TDI 3, even after the change for a given feature, it is still number 1. So it means it is a generic one worth investing because it helps a lot of features in the first place. Okay, in theory, theory practice are the same, but in practice, unfortunately, not. So let's discuss what happened during empirical evaluation. We use it for camera configuration tool. This is the tool to enable configuration of cameras which are being discovered on the network. Initially, it was created only to support Avigilon cameras, but after acquisitions like Pelco, Indigo Vision, and other, we make it Motorola Solutions wide tool, and also supporting other third-party cameras. It has like 250,000 lines of code. In 2020, we started at the very beginning, like in February, March, defining the scope for working here in Krakow, because it was the time of the transition, and started thinking about what we can do to improve it, because there was quite a few technical challenges we faced. Then the pandemic hit in March. Then in June, we saw that there are several acquisitions. First of all, Indigo Vision. A couple of months later, this was Pelco. And the prioritization of the business perspective changed a lot to support these new opportunities. So we started defining this technical debt register and trying to map to which functionalities it is really helpful and how it may support upcoming product changes. What we see in the bottom right corner is actual resolution of our actual situation, how our experiment was conducted. The blue line shows the ideal evaluation, how we should have been following the technical debt recommendation from CoDVA. The red one is how we tried to follow it. So why the difference? Also, there were two more aspects to being taken care of and thought through. When you have too big technical debt item, it is being constantly postponed. You cannot squeeze it into a given release. Only after it was split in a couple of items, it was able to finally be finalized in a couple of subsequent releases. So this was one aspect. Second aspect, for engineers, it is easy and also less time consuming to work in the same area. So when code was open in a given area, so even if technical debt item was a little bit later on the roadmap, it was simply taken because it was faster to add additional change to a given feature of functionality. But anyways, the guideline, which was provided by CoDVA, was like a North Star to which the team was trying to adhere. Considering this experiment, we also did one initial evaluation. We tried to think whether there is really value to try to engage way more business perspective. Maybe engineers have a good view by themselves. So even this real CoDVA example I showed, which was not the ideal perspective you wanted to follow, was better by 27%. It means that in initial engineering choice, what they would have done if there were no other guidelines would simply hit a different product areas, which would not be that beneficial for the future. Going further, considering productivity, engineering velocity after all of these changes increased by 39%. We had the period of severe changes considering technical debt. After that, we had some stabilization period, and we checked the values before and after. Considering productivity, also we thought about releasability. So how fast we can release the product out of the door. So the question here, which we asked ourselves, was how many different additional software checks, so full regression runs, are required. If there was a severe issue in the product, we simply need to rerun the whole regression. And this couple 6 times at the first release. However, at the end, it seemed that there were no critical issues which required full regression runs, which means that the product got way more stabilized. And last but not least, delivery predictability. All of the goals we wanted to achieve, so like sprint goals, some performance goals, whatever was defined, where we landed after the experiment, it was the improve of 60%. So what we wanted, it was achieved. Going further, trying to think about also some metrics from engineering perspective, there was a survey which took into account many aspects of software engineering life cycle, thinking about working on the defects, bugs, issues, amount of mundane tasks which are not helpful to move things forward, and going through pipelines, quality of the testing, of the product code, and decisions. When you see these responses, they are heavily shifted to the right, which means that many of the people sees them beneficial, the results of the experiment. However, we see this is like a piece which is working on the product backend issues, which became actually higher. And we had a couple of open questions, and here's the importance of the methodological triangulation. When we have different ways of measuring the same things to get some more insight. On one hand, we saw it takes more time, but on the other hand, there were a couple of open questions, and engineers said that actually they found out that they spent more time on defect fixing, but they are doing it in a different way. Easy to fix or small ticket items simply disappeared first, and later on they try to use defects to refactor certain areas of the code, more challenging issues to address, which were of architectural, for example, origin. And they actually even had some meetings which were focused on thinking how and what may be improved and what are the challenges. So that's why it took more time. So ultimately, it was a good information because it showed a different angle on how the engineering thinks about quality of the product. So ultimately, let's sum up the whole overview and the presentation. So first of all, what is really important is that continuous depth valuation approach takes into account broadened product view. So everything which creates value for customers, everything which takes into account different aspects of software engineering, and actually it shifts the thinking of fixing technical debt to what will be needed in the future. Also, we employed here decision-making autonomy, which means that from business perspective, we have product managers who provide us clear guidance on the roadmap and how this is going to be assigned to a subsequent product releases. When there are changes happening, that's okay, but we have a clear understanding in any given moment what is the perspective of the business. And this is the decision from the business perspective. On the other hand, from engineering perspective, we identify technical debt. So having the technical debt register, having them mapped on the features, so each time the priorities are changed, the priorities of the business, they are automatically changing the priorities on the roadmap of technical debt. Additionally, instead of like adding some heavy process, this was put into the Scrum framework. So when we have the refinements, we simply identify technical debts. When we are discussing about plannings, technical debt is simply another aspect being taken care of. So there is no need for additional heavy process, which sometimes may be abandoned after some time. And last but not least, it is simply showing how we may engage business stakeholders, and they have influence on what engineering is working on. They are not defined specific items, but they are defining the areas which will be important for the future. So looking into rearview mirror, what actually happened? CoDVA actually balanced the engineering view, identifying technical debt, with the business view, how we may prioritize it. And then the values which I already mentioned, business value increased. This was the CoDVA metric, which is simply assigned to how the features are being prioritized by business. Then we have productivity improvements, velocity increased, delivery predictability, and last but not least, effort spent on product stabilization decreased by 50%. Last but not least, we saw that developer satisfaction developer satisfaction actually grew, and across the whole product, not only about the working on it, but also about decision being made, and the satisfaction from testings, from pipelines, for the way how the product is evolving. So lastly, I would like to cover also the limitations. Excuse me. When we have unstable development environment and development process, so simply it's too early to add additional thinking. We simply need to have the process in place. Once we have a clear understanding how the team is working, how stable Scrum is being introduced, we can add this additional ingredient to the framework. When the product is very mature, and mostly this is maintenance, additional evaluation, additional changes might be simply too late, because there's simply no big expectations for the product. But the ideal state is when actually we do have a big amount of changes coming. We have stable Scrum process, so the team knows how to work with each other. They simply have the challenges, and there's simply too much to do. And actually, the roadmap is really, really big. So for that, we need to have a structured business process. This is one prerequisite. So we will know what is coming in the upcoming releases. And this may change, but this will not change 100% of the time after each release, because then this long-term planning has limited value. On the other hand, also very important aspect is communication. We do want to redirect this business engineering tension over budgeting technical debt towards technical debt consequences. We simply need to measure it, show it, and understand where we are. So the big question is how much to spend on technical debt reduction, whether 20%, which is kind of number which can be found in literature, is good enough or not, is too big or too little. The simple answer is, yeah, it depends. However, how we can measure it, how we can think about it. If it is too little, we are simply seeing that the velocity started dropping, satisfaction is dropping, so we see the consequences. If we are reaching this tipping point, it simply slowly starts to increase and improve. And actually, this needs to be evaluated as we go. Sometimes we need to invest way more than 20%. Sometimes 10% will be good enough. It depends on the amount of the changes and the quality of the internal product structure. So if I would have one thought to leave this presentation, after this presentation to think of, is the quote from Wayne Gretzky, the famous hockey player. I skate to where the puck is going to be, not to where it has been. So in similar way, our CoDVA approach is going to show the areas worth investing considering future, rather than the areas in which we are working right now. And why it's important? Because what's the value for technical debt in the area of the code, which is good enough for customers? We see maybe not that much pretty, but no one simply wants to invest adding additional features. So there's no future plans to improve it. It is good enough. So simply the technical debt value should be 0. However, when we think about the product, even with a small technical debt, but which will be extensively developed going forward, so a given module will be like a cornerstone for a couple of new functionalities, then definitely the technical debt value for that item is high and requires attention. Okay, with that, I believe that's all from the slides I wanted to share with you. And now I open for the question.